Red on V, black on COM. Read the number, done. That's how everybody learns it, and that's exactly why you never find the fault. This is not dead yet. We bring electronics back that were already sitting in the bin, and step 1 is always the same. Measure. Measure properly. So this is our how to use your multimeter like a pro tutorial. Most people own a multimeter. Almost nobody uses more than 2 of its functions. That is a shame because the meter sitting on your bench can tell you exactly why a board is dead. It can identify a shorted diode, a leaky capacitor, a broken trace, a blown fuse in under a minute, if you know which mode to turn to. So today we are going through every single function of a proper bench meter, the Fluke 179, and what each one is actually good for. Not the manual version, the version you use when something is broken. Let's get into it. First, the single most important spec on any meter you buy, true RMS. The Fluke 179 is a true RMS meter. That means it calculates the real effective value of whatever waveform you feed it. A cheap meter does something different. It measures the average and multiplies by a fixed correction factor. That factor only works for one specific waveform, a clean sine wave. So on a wall outlet, both meters agree. Fine. But the moment you measure something modern, they stop agreeing. A switch mode power supply, a motor controller, a light dimmer, a PWM signal, any of those, and the cheap meter is not slightly off. It is meaningfully wrong. It will hand you a number that looks plausible and send you chasing a fault that does not exist. That is the entire argument. If you are troubleshooting real electronics, you need a reading you can trust. And true RMS is what buys you that trust. The 179 gives you a 3 3/4 digit display with a 6000 count resolution and a bar graph. And during any voltage measurement, it warns you on screen if it detects a potentially dangerous voltage. That is a feature you appreciate exactly once, and then you never want a meter without it again. Now the dial. Every position has a primary function, and most have a second function hidden behind the yellow button. A C-volt measures the effective value of alternating voltage. Press yellow and you get frequency in Hertz instead. Use it for mains voltage, transformer outputs, and hunting down noise. DC volts, batteries, power supply rails, anything steady. This is where you will spend most of your time. Millivolts, DC, for very small voltages, sensor outputs, shunt measurements, low-level signals. On the 179 specifically, the second function here is temperature, using an external Type K thermocouple. Ohms, resistance, and behind the yellow button, capacitance. Yes, your meter measures capacitors. Most people never find out. Continuity, the beep function, fast cable and trace checking. Second function, diode test, which measures forward voltage drop across a junction. Milliamps, small currents up to 400 milliamps. Second function switches between AC and DC current. Amps, up to 10 amps through its own separate jack and its own fuse, for short duration measurements only. 4 buttons you should actually know. Hold. One press freezes the display, extremely useful when your probes are somewhere awkward and you cannot look at the screen at the same time. Hold the button for 1 second to release it. Min-max starts a recording session. The meter tracks minimum, maximum and average and beeps every time it captures a new extreme. This is how you catch an intermittent fault. Clip the leads on, let it run, walk away. Range. Toggles between auto ranging and manual range selection. In manual mode, every press steps up 1 range. Manual is slower to set up but gives you better resolution and stops the meter hunting around on a noisy signal. The yellow button selects the alternate function of whatever the dial is pointing at. Hertz, temperature, capacitance, diode test, AC versus DC current. This one button roughly doubles what your meter can do. 4 jacks. Get this wrong and you destroy something. The V-ohm jack takes the red lead, for voltage, resistance, diode test, continuity and capacitance. The milliamp jack takes the red lead for currents up to 400 milliamps. It is internally fused. The 10 amp jack is separate with its own fuse for currents up to 10 amps. Short measurements only. COM takes the black lead. Always. Connect COM first, then the other lead. And here is the rule that matters more than any other rule in this video. When you measure current, the meter goes in series. You break the circuit and you put the meter into the gap so the current flows through it. In current mode, the meter is almost a dead short between its two jacks. That is by design, which means if you leave your red lead in a current jack and then go measure a voltage, you are placing a dead short directly across that voltage source. Best case, you blow the internal fuse. Worst case, on a main circuit you get an arc flash in your hand, so build the habit. After every current measurement, move the red lead back to the V ohm jack immediately, not later, immediately. You have seen CAT ratings printed on test leads and probably ignored them. Here is what they mean in one sentence each. CAT 2, 1000 volts, and devices the socket outlet side, rated for transient over voltage events in final branch circuits. CAT 3, 1000 volts, distribution level, panels, switchgear, considerably more available energy than CAT 2. CAT 4, 600 volts, the service entrance, the utility connection, the highest category for outdoor and supply side work. Why this matters? The category is not about the steady voltage, it is about the transient energy the leads and the meter can survive when something upstream goes wrong. A higher category at the lower voltage is a tougher rating than it looks. The rule is simple. Your test leads must carry at least the same CAT rating as the environment you are measuring in. Undersized leads are how you get an arc across your hands instead of a reading on your screen. Before every single measurement, 6 things. Inspect the test leads for damage, especially where the cable meets the plug and the probe. That is where they fail. Connect COM first, then the measuring lead. For current measurements, power down the circuit first, then break it, then insert the meter in series. Watch the battery indicator. A weak battery gives you wrong readings, not no readings. Discharge capacitors before any resistance or capacitance measurement, and never measure outside the specified voltage, current or CAT limits of your equipment. That takes 10 seconds and it is the difference between a routine day and a very bad one. That is the instrument. Not just volts and beeps, but a dial where almost every position has a second function hiding behind that yellow button, 4 jacks that each have a job, and a set of safety rules that take 10 seconds and save you a very bad day. Before you measure anything, the workflow is always the same. Check your leads, choose the right jack, set the function. COM first. Measure, remove the leads, power down. Thanks for watching this one through. If it was useful, a like genuinely helps the channel, and subscribing means you will not miss part 2, because part 2 is the fun half. We take everything from this video and we actually use it. 11 measurements together, from mains voltage to a 220 microfarad capacitor, from a diode test to checking whether a transistor is dead. Same meter, real components, start to finish. Bring your multimeter. I will see you there. Because it is not dead yet.